Right, so today we're going to look at the quotient of powers property. And this property is useful when we're trying to divide powers. And the way it looks is you have a base raised to the m power, let's say, divided by the same base number raised to the different power. And when you're trying to simplify this, the rule says that you're going to take the same base and just subtract the exponents. Okay, now keep in mind that the m is the one that goes first and then the n is the one being subtracted. If you were to write them the other way around, then you would get a wrong answer. Sometimes you will end up with subtraction leading to a negative number, but we'll get to that later. So in this particular section, we'll stick to positive exponents. And if I give you an example of what that looks like with a real number, say you have let's say 4 to the 5th power divided by 4 to the 2nd power. So what that means is you have 4 multiplied with itself 5 times, all divided by 4 multiplied by itself 2 times. So that's what 4 to the 5th power means, and this is what 4 to the 2nd power means. Now, when you're doing this, you also think about what we have here. We have 4 divided by 4, 4 divided by 4, and then 4 times 4 times 4. Okay, so again, 4 divided by 4, 4 divided by 4, and then 4 times 4 times 4. Now, we could actually consider these to be a 1. Okay, so 4 divided by 4 is 1. Another 4 divided by 4 is another 1, which now I'm left with 4 times 4 times 4. So I'm going to go ahead and just rewrite everything we just said. So that means I have 1. 4 divided by 4 is 1. Another 4 divided by 4 is another 1. Times 4 times 4 times 4. Okay. So now, this expression, clearly 1 times 1 is irrelevant because nothing changes when you multiply it by 1. So now we're just left with 4 to the 3rd power. And that is my answer. Okay, so how could I have gotten from here all the way to here and not having to write all of this expanded form? And that is the rule, right? The rule was to take 5, subtract 2, and you got 3, right? Because if I'm going to cancel these out, and why am I canceling them out? Because I know that the 1s don't change the problem. So technically I'm saying cancel, cancel, they're both 1s. And remember, when you're canceling, you have less of something. So when you're canceling, you have less of something, and that's why the subtraction comes into play. Because now we have 2 less in the exponent, which is 3. All right, so let's apply this to our first example. That was just an example to show you how the property works. Now I want you to do an example using the shortcut for this property. We don't want to have to write it all out in expanded form and waste some time. Let's save some time. So 2 to the 6th divided by 2 to the 4th. And then we got negative 7 to the 9th divided by negative 7 to the 3rd. And then C says h to the 7th power divided by h to the 6th power. All right, so now let's see. I'm going to use a different color. Let's try green. So the rule says, if I know I'm going to have 2 times 2 times 2 times 2 times 2 divided by 2 times 2 times 2 times 2, there's going to be some numbers that cancel, right? Since I know some of them are going to cancel, I'm just going to cut to the chase and use my rule that says I take 6, subtract 4, and I know I'm going to be left with just 2 of them that did not cancel. Okay, and now let's look at B. So again, I have negative 7 as my base, and I had 9 of them up here, 3 of them down here. 3 pairs will cancel, so I'll have 3 invisible ones, and I'm still going to be left with 6 because 9 take away 3. Leave me with negative 7 to the 6th power. Okay. And now example C, 7 and 6. So this equals h to the 7 minus 6 power, which is h to the first power. Now, h to the first power, we don't need to put a 1 if you already see that there's an h there, so you could just leave it as 1h. Okay. All right, so here's example 2. Example 2 asks me to simplify this. Now, I notice that it's got multiplication on the numerator, and then after that gets simplified, I will have to divide it by 3 to the third. So it's going to be a two-step process. I'm going to use what I've learned previously with my numerator. And I've learned that if I have the same base raised to two different powers, that is called product of powers. And product of powers means you keep the same base, but if I have 4 multiplied here and 2 more 3's are multiplied here, now I have a total of 4 plus 2, which leads me to 3 to the 6th power. Okay, that's for my numerator. And then my denominator, I'm still going to have that 3 to the third. So now this looks like a quotient problem. Quotient of powers. So quotient of powers says 6 take away 3. And I know that 6 take away 3 is 3. Okay, so notice we used the product of powers here and the quotient of powers here. All right, let me just do one more, just like example 2, so we get a little more practice. We'll call this example 2A, and let's do a B. So you have 5 to the 6th power times 5 to the 2nd power, all divided by 5 to the 4th power. And again, you have the product of powers in the numerator. So that's going to be 5 to the, you add up the exponents, 6 plus 2. And if I have 5 multiplied 6 times, 5 multiplied 2 times, the rule was to add them up and get a total of 5 being multiplied 8 times altogether. Still being divided by 5 to the 4th. And now I have my quotient rule here. Take the first exponent, subtract it from the bottom one, subtract it by the bottom one, and you get 5 to the 4th power. So there you go. Now you are going to be able to use these rules whenever you find them necessary in any problem, as long as it's proper and you can simplify anything that looks complex like this.